Hey again. So in this video I'm going to show you guys how to simplify rational expressions. Now I know you're not completely familiar with what a rational expression is, so I'm going to get to that, but I want to start by talking about something that you kind of already know about, right? But just showing you a little bit of a different way to do it. So I want you guys to consider the following fraction. So 10 over 15, right? So we know that that's a fraction. You can probably tell that that's not in lowest terms, right? 10 over 15 is not in lowest terms. In fact, you might actually be good enough with fractions that you can actually already tell what that would be in lowest terms. So you probably recognize that that's going to give you 2 over 3 because both 10 and 15 rather are divisible by 5. Okay, so you would divide each by 5. So you could do that, where you divide the top and the bottom by the same number, and that would put it in your lowest terms. I'm going to show you guys a slightly different way to simplify that, right? To put it in lowest terms, because it's going to be using this. It's the same method that we're going to be using for rational expressions. So here's the thing: we can start by taking 10, right, and factoring 10. Now remember, we're used to factoring expressions. Factoring a number just means finding two numbers that multiply to give you that number, right? So we're gonna factor 10, and to factor 10, well, we know that 10 is just 5 times 2, and 15 we're gonna factor 2, and that gives us 5 times 3. So in other words, 10 over 15 can be written as 5 times 2 over 5 times 3. Now I want you to notice that there is a factor of 5 at the top and there's a factor of 5 on the bottom. So we have a common factor of 5 on the top and the bottom. Now what that means is that those 5s are going to cancel, okay, and all we're going to be left with is 2 over 3. Okay, so this is another way that you could have that you can simplify a fraction, right? You can put it in lowest terms is by factoring the numerator and the denominator, right? Canceling any common factors, and then writing your answer after you cancel the common factors. Okay, so now that we've seen that, right, we're going to use that same method for rational expressions. So let's take a look at what a rational expression even is first. So this is going to be a rational expression, 2x squared plus 5x plus 3 over x squared plus 5x plus 4. So it's a rational expression because what we're doing here is we're taking two polynomials, right? So 2x squared plus 5x plus 3, that's a polynomial. And x squared plus 5x plus 4, that's another polynomial. And we're basically putting them into a fraction. So one of them is our numerator, one of them is our denominator. So now we're dealing with fractions but with polynomials, okay? So we want to simplify this, right? Now we don't know what's simplifiable technically, right? Not every fraction is simplifiable and not every rational function is simplifiable. This one is. But I'm going to show you how to simplify it, okay? And it's going to be exactly the same method that we used up above there. So remember that the first thing that we did was we factored 10 and we factored 15. So we factored the numerator and the denominator. Well, we know how to factor numbers. We also know how to factor polynomials. So we're going to factor 2x squared plus 5x plus 3, and we're going to factor x squared plus 5x plus 4. So factoring 2x squared plus 5x plus 3, so I'm not going to go through all the little details about how to factor that. You guys should know how to do that by now. But it's going to leave you with x plus 1 times 2x plus 3. So you can double check that if you want, but 2x squared plus 5x plus 3 does factor into x plus 1 times 2x plus 3. Okay? And I'm going to factor the bottom, and just like I did with the first one, I'm going to put down what it factors into, but you guys can check it. So we're going to get over x plus 4 times x plus 1. Good, so we factored the numerator, we factored the denominator, and we ended up getting this. Now I want to point out something to you guys, right? I want you to notice that we've got x plus 1 in our numerator, and we have x plus 1 in our denominator. So we have a common factor. We have a factor of x plus 1 up top and a factor of x plus 1 on the bottom. Now, just like in our first example when we had a common factor of 5 that we canceled, we can actually cancel these common factors. So x plus 1 and x plus 1 cancel with one another. And that's going to leave us with 2x plus 3 up top and x plus 4 on the bottom. So this is actually now fully simplified, but that's it. We've simplified this rational expression, okay, by canceling the common factor. Now, there is one little thing that I want to point out, though, okay? So because we're using the equal signs right here, we're trying to say that the expression at the bottom is the same as the expression up top, okay? Now, they are pretty much equivalent, but there is one important difference, namely that there are actually two x values that you are not allowed to substitute into the original expression that we had, right? And why is that? Well, there's actually going to be two different x values that are going to make our denominator equal to 0. Okay? Now, in our in our simplified version, right, this guy down here, right, we're only going to have one x value that's going to make our denominator equal to 0. So we can't really say that they are the same using our equal signs yet. So what we need to do is we need to list our restrictions. So that's what we're going to do next. So our restrictions. So all restrictions are the x values that make the original expression, right, have a denominator equal to 0, right? And the idea is that you're not allowed to have those in the expression, so therefore you're not allowed to have them in the simplified version either. Okay? So easy way to find your restrictions is you are going to look to the part of the question where you fully factored. So that's going to be right in that line there. And I want you to notice that the denominator, factored into x plus 4 times x plus 1. Now, the idea is if the denominator is equal to 0, then either one of those factors would be equal to 0. Okay? And remember, we're not allowed to have 0 in our denominator. So basically, we're not allowed to set x equal to -4 or -1, because that would make our denominator equal to 0. So we say that our restrictions for this expression are x does not equal to -4 and x does not equal to -1. And those are our restrictions. So this is the full process of how to simplify rational expressions and state the restrictions on the x values. Take care, guys.